Hello students. So today we are going to work out JEE Main previous year questions this year 2024 January session. Okay, that will give us more exposure about the recent type of questions coming. So let us start. A particle is moving in one dimension along x-axis under the action of a variable force. Its initial position was 16 meters right of origin. The variation of its position with time is given as. Okay, so x is varying with time. They have given this, right? Where x is in meter, time is second. Okay, the velocity of the particle when its acceleration becomes 0 is. We have to find out velocity when acceleration is 0. So we need to calculate acceleration first and then equate to 0. Okay, and then we'll get the time, and that time we'll put in velocity, right? So what is velocity? Velocity is dx by dt. So let's differentiate. First term, minus 3 comes out. T cube differentiation is 3t square. Next term, 18 comes out. T square differentiation is 2t. Plus last term, 16t. 16 comes out. T differentiation is 1. Right? So then this is the velocity. What is the velocity? Minus 9t square plus 36t plus 16. Now we'll calculate acceleration. Acceleration is dv by dt. So again differentiate. Minus 9 comes out. T square differentiation 2t plus 36 comes out. T differentiation is 1. 16 is constant. Differentiation is 0. So now we have to put this acceleration equal to 0. So from here, what do we get? T. So T is 36 by 18, which will be 2 seconds. So we got the time first of all. Once we calculated this time, then what we need to do? We need to substitute back in the velocity. Right? They are asking this velocity is given. In this, we need to substitute this time. So let us substitute the time and calculate velocity. So velocity will be 9 minus 9 t square 2 square plus 36 into 2 plus 16. So how much this is going to come? This is minus 36 plus 72 plus 16, isn't it? So from here, what do we get? 36 plus 16. So finally we can get how much? 52. Correct. We can see that final answer is 52. 52 meter per second. Right? 52 meter per second. Okay. Let's move to the next question. Next question. Train A is moving along two parallel tracks towards north with a speed this, and train B is moving towards south with a speed this. Velocity of train B with respect to A and velocity of ground with respect to B. Okay, so first of all, these velocities we should try to convert into meter per second, right? So velocity of A is 2 km per hour north. I think here we need to take some direction because velocity has direction, right? So if you take towards north, so it is in this direction, right? And towards south in this direction. So velocity of A will be upward. Upward means front, and the velocity of this is backward. Okay, because this north, south, east, west is defined horizontal plane, right? So VA, how much? 2 km per hour, right? So we can multiply 2 into 5 by 18, 5 by 18, and then similarly VB, I think it cannot be 2, maybe it is 72, something is missing here. Okay, similarly 108 5 by 18, multiply. So what does this comes? I think from here we can see 6 into 5, 30 comes, right? I think this will be 72. Okay, isn't it? It will be 72. So there is a mistake here. This is 72. Okay. So this is 72. So 72 into 5, then it will come 20. Okay, 20 meter per second, 30 meter per second. Okay, so then what is the velocity of A? We have to also keep signs, right? Signs. So plus minus we can keep, suppose, but here they have not given the sign, isn't it? Suppose if you take upward positive, downward negative. So they are asking velocity of B with respect to A. Velocity of B with respect to A, velocity of B minus velocity of A. So velocity of B is minus 30 minus velocity of A. Velocity of A 20. So we get minus 50. Okay. Now what is velocity of ground with respect to B? So velocity of B is actually with respect to ground itself. Right? Velocity of B is with respect to ground. That is what is given as minus 30. Okay, so if I choose velocity of ground with respect to B, so this is minus of velocity of ground with respect to, right, B. So from here we can say velocity of ground with respect to B, that will become 30 meter per second. Okay, so in this question we should give sign, because plus minus sign should be defined, right? We cannot say just one sign. So if it is speed, let's say if it is speed, so speed means we have to keep, of course, positive, both terms positive we have to keep, but they are certainly giving velocities, so we should associate some sign, and sign convention is normal, plus minus according to the whether it is going front, back, or left, right, like that we can check that. So this relative velocity is minus 50 and this is 30. So we can go with option 3. Okay, next question. A particle initially at rest starts moving from reference point x is equal to 0 along x-axis. Velocity varies. Velocity is given as a function of x, right? Acceleration. So we know acceleration can be dv by dt, or it can be v dv by dx. So here we should use v dv by dx. Why? Because v is a function of x. Okay. So let's do that differentiation. So v is 4 root x, and then differentiate v. So differentiate 4 root x with respect to x. So what will happen? Let's do that. 4 root x, 4 will come out here. Root x is 1 by 2 root x. I think this root x is getting cancelled, isn't it? So we can cancel it. Root x cancel. So we are getting 16 meter per second square. So obviously, and that's the answer, 16 meter per second square, right? If you want another approach, another shortcut approach can be, if you square this, v square is equal to 16 x it will be, correct? V square is equal to 16x. So if we have to calculate, I think here 2 will get cancelled, isn't it? So 16 by 2, 8 is coming answer, right? 8 is the answer, right? Here another approach is v square is equal to u square plus 2x. If you consider initial velocity rest, so v square is equal to u square plus 2ax. So u is anyway 0. This is 2ax. So that means 2ax. Here 2a is the coefficient of this x. That means we can directly compare 2a is equal to 16. So a will become equal to 8. Okay. This approach can be only used when it's a constant acceleration, or v is proportional to root of x, right? Otherwise this approach, this second approach that we are using it here, that's a fundamental approach. We should go with this in case if things are given different. Okay, let's move next. Next question. Particle start from origin at time 0 with a velocity this and moves in xy plane under the action of a force which produces constant acceleration. The x coordinate of the particle at the instant is this. Then the speed of the particle at this time is root alpha. So at a particular time we have to calculate. So x coordinate they have given, right? It is starting from origin. So initial coordinate is 0, 0, right? This is time 0 at origin, the body is there. And it is moving with a velocity. So initial velocity is only along x-axis, right? Initial velocity. So if you want, you can divide it into different groups along x-axis and y-axis. So y-axis velocity initially is 0. X-axis velocity is 5, right? 5 I cap means along a positive x-axis. Okay, moves in xy plane. This is the constant acceleration. So acceleration along x-axis is 3 and acceleration along y-axis is 2. If the x coordinate of particle at some instant, so some instant, let us say it is here, x coordinate is given as 84. Y coordinate we don't know, right? We don't know y coordinate. What is y? Okay, y is something, it will leave it. Then the speed of the particle at this time is, here what is the speed they are asking. So here also you can calculate the x component of velocity and y component of velocity. Okay, calculate both the component, then speed we can calculate as root under vx square plus vy square. So how to calculate? First of all, they have given this information 84. So let's use that. X is equal to ut plus half at square, right? We can use that. So let's use that equation. X is equal to ut plus half at square. This we should use along x-axis. So all this is along x-axis. X is 84. Initial velocity along x-axis is 5. T plus half acceleration along this is 3, right? T square. So from here we are getting an equation. What it is? 3t square plus 10t minus 4 to 8 and 8 to 16, right? Is equal to 0. Now from here time we can calculate. So how much the time will be, that we need to calculate. Okay. Yes, so what will be the time? This is a quadratic equation, we can solve this. Let's solve this time. Minus b plus minus, right? Minus b plus minus root under b square. B square means 10 square, that is 100, minus 4ac minus minus plus 4 ac, 3 into 168, right? Divided by 2a, 2 into 3. How much this time comes? First we need to do this calculation, right? So just check how much this time will come. So 12 and 168 multiply, how much it comes? 6, right? And 6 into 2, 12 plus 1, 13, 3, 1, 2, 1, 3, correct? And this is 168. So this comes 8, 3, 11, 6, 3, 9, 1, 10, 1, 2016. Now 2016 plus 100. 100 we add, so 2116. Now 2116, what it is? First of all, we need to think about 2116. 2116 under root we have to calculate. Okay, 2116. How do you calculate the under root? See, all this is calculations I am doing so that you know how to do this basic calculations. 2116. So think about it. Square root calculations, right? So if you calculate this under root, let us say like this, square root calculations. So 339, 4416, 4416 you take, right? So if you take 16, here 4 you have to add 8, right? And this is going to be 5, and this 5 1 6 will come together. So 6 if you keep 6 how much comes? 6 36 3, right? It is 48. Yes, I think this is the square root. 46 is the square root of it. So we should know how to calculate the square root, right? So once you know how to calculate the square root, then let us see. So this is 46 is coming inside the root. Okay. So time will be minus 10 plus minus 46 by 6. So time can be calculated now. So of course it cannot be negative. So take plus 46. So plus 46. So this will be 36. 36 by 6 is 6 seconds. 6 seconds. Once you get this 6 seconds, then you can calculate velocity along x-axis, velocity along y-axis, isn't it? So what is velocity along x-axis? U plus at, right? So initial velocity is 5 plus acceleration along x-axis is 3, the t is 6. Now how much it is? 6 into 3, 18. 18 plus 5, it will be 23, right? Meter per second. Similarly, velocity along y-axis equal to u plus at. Y-axis velocity was 0 initially, so 0 plus acceleration is 2 into 6, so that will become 12 meter per second. Now finally the speed root under vx square plus vy square. So how much this will give? This will be root under 23 square plus, again little calculation is coming, right? So what is the square of this? Square root we need to calculate, correct? So what is the square root of this 23 square? If you remember, that's good, right? So 23, otherwise suppose if I don't remember, then I will calculate this, no problem. But only thing is we have to do fast calculation, right? So 46, so I think this is 529, right? 529. So 529 plus 144 whole square. So this becomes 3, right? And 4 2 6 1 7, right? And 5 1 6 673. 673. Now 673. What is the root of 673? Yes. What is the root of 673? It looks like an odd number. Near about we can calculate. Yes. How much it will come? So if it is 25, it is 625. After 25, 26 you take. 26 square is how much? 15, 52. I think that is nearest, right? 676, that is. So we can go for that. 676 means near to 26 meter per second. Okay, that will be the answer, 26 meters. So calculation we have to practice. But I think here they are asking under root itself, right? They are giving, they are not asking this. So that means we can just keep under root this. So this is alpha, right? Root alpha they are asking. So that is 676. 673, right? Okay, let's move next. Next question, bullet is fired from fixed target, loses 1/3 of its velocity after traveling 4 centimeters. It penetrates further this, right? Before coming to rest, the value of d is. So this is 4 centimeter, right? If you keep in everything is in meter, so this will be 0.04 meter. So this bullet which is going, okay, this is a particle bullet, right? This bullet is moving, right? And it loses 1/3 of its velocity. So suppose here velocity is u. After passing this, its velocity becomes 1/3 u by 3, and this is 4 centimeters, right? 4 centimeter. It penetrates further this to come, and then it is saying inside only. Let's say it is going inside only, so we have to just consider this motion inside only. Let's take it is still going inside. So if it is still going inside, you can further let us say that it's moving a distance of x further, and then it will become stop, right? It will be stop, means stop, final velocity will be 0. So they are asking what is the distance x. X is given in terms of this, so we can just apply, assuming constant accelerations, we can apply v square minus u square is equal to 2ax. So if you apply this retardation, it will be, so you can write initial minus final, or if you want you can use final. If you final square, v square minus u square, initial square is 2a into x. X is 4 centimeter, right? If you keep 4 centimeter in meters, so 4 into 10 power minus 2. Similarly, this next equation will be final velocity square, 0 square minus u by 3 square is equal to 2a into x. X is in meter, so this equation 1 and 2, now you can divide. Now you can divide second divided by first. What do you get? Let's say that. So minus will be coming u square by 9. Next, here you have taken 9 as LCM, so minus will be there here also, and u square will be there, and here it is like 1 by 9 minus 1, right? So basically 1 minus 9, right? So minus 8 by 9. Okay, and this will be 2a factor will get cancelled. It will be x into 4 x by 4 into 10 power minus 2, right? So from here you can easily calculate this. So we can just minus cancel, u square by 9, u square by 9 cancel. So x is going to be 4 by 8 into 10 power minus 2. So this is 0.5 into 10 power minus 2. That means it is 5 into 10 to the power minus 3. Okay, so this is the value of d that they are asking. The correct answer will be option 2. Okay, so like that we can continue. Next, let us move next. Next is a body falling under gravity covers 2 points A and B separated by 80 meter in 2 seconds. Okay, so a body is falling freely. This is a motion under gravity portion. So 2 points A and B, this distance is 80 meter and it is being covered in 2 seconds. Okay, the distance of upper point A from the starting point is, the starting point, let's say O. Okay, this distance we have to calculate. Let's say this is x. Okay, body falling under gravity. So initially you would have started with 0 speed, right? Because generally it is like a case where it is dropped, right? So when the body is dropped, so initial speed is 0, right? Initial speed u is equal to 0. Now in 2 seconds it is covering this. Here some velocity will be there, here also some velocity will be there, right? So we need to calculate x, but speed we don't know what is the speed, right? X is equal to ut plus half at square. If you use initial velocity 0, so half t square, isn't it? So suppose if I use this distance right from very beginning, if you see this distance is x, so this distance will be x plus 80, isn't it? So if I use x is ut plus half at square, u is 0 from beginning, so x is equal to just half g t square. Here time we don't know, let's say time is taken as t. Okay, so here time will be how much? T plus 2. So half g t square if we take, and then x plus 80 will be half g t plus 2 whole square, right? So we have got this equation 1 and we have got this equation 2. So can we solve these equations, isn't it? We can subtract the time we get, and then we can just substitute, right? So let's just subtract it. So 2 minus 1 if you do, we'll get 80. 80 will be half g, then t plus 2 whole square minus t square. So you can use a plus b square, a square minus b square, right? So a square minus b square is a plus b, a minus b. So a plus b you'll get, this will get 2t plus 2, right? And if you do a minus b, you get only 2, right? So from here, now 1, 2 can be cancelled, isn't it? And another 2 can be taken as common. So from here, it is equal to g is 10, so 20 t plus 1. So this will become 4 this side, and t will become 4 minus 1 3 second. Once you get t, then you can substitute in first equation, because x only you want to calculate. So x will be half g is 10 and time is 3, so 3 square, right, 9. So this will become 5 into 9, 45 meters, right? That will be the final answer, 45 meters. Okay, so like this we can solve. Next, a body starts moving from rest with constant acceleration, cover displacement s1 in first p minus 1 second, s2 in first p second. The displacement in s1 plus s2 will be. So first p seconds, p minus 1 second means from time 0 to time, let's say p minus 1, right? And then p second means it will be here, right, greater than this. Okay, so this displacement they have given as s1, and first p seconds means from here to here, this is the displacement s2, correct, right? This is s1 is the first p minus 1 second, and then first p seconds. Okay, displacement s1 plus s2 will be made in time. Now they are saying a displacement of s1 plus s2 we have to make, s1 plus s2 starting from 0 itself. How much time it will take? This time they are asking. So we can just write the equation of s1. S1 will be initial velocity starting 0, so u0, half at square, s is ut plus half at square. Acceleration is constant, so first will be t means p minus 1 whole square. Similarly, s2 will be half a p square, right? Now what they are asking is s1 plus s2. S1 plus s2 should be half a t square. This time we have to calculate. Okay, now you substitute s1 plus s2. So when you put s1 plus s2, half a will come common. So it will become p minus 1 whole square plus p square, right? So this will be half a t square. So from here, half a got cancelled. So t will be calculated as under root that you simplify. So when you open up this, so p square will become 2p square, right? And minus 2p will be there and plus 1 will be there. So isn't it, this much time it will take? So that is the option number 2, right? Then let's move next. Particle is moving in a straight line. The variation of position x is given. Velocity, similar type of question it is. So we have to calculate velocity and acceleration. So velocity differentiate, 3t cube is t square minus 6t square is 2t plus 20 into 1, constant differentiation 0. So velocity we got is 3t square minus 12t plus 20. Acceleration dv by dt. Differentiate velocity further. So 3 into t square differentiation 2t minus 12 into 1, constant differentiation 0, and acceleration should be 0. So from here t comes as 12 by 6, 2 seconds, correct? Once you get this, you substitute in velocity. So velocity you substitute times 3 into 2 square minus 12 into 2 plus 20. So how much it comes? This is 12, right? 12 minus 24 plus 20. So how much this comes? 20 plus 30 12. This is 32. 32 minus 24. So this gives us 8, right? 8 meters per second. Similar model, I think it is from different shifts, right? Similar question from different shift. Okay, let's go next. Next is particle is moving in a circle of radius, okay, such a way that at any instant the normal and tangential component of acceleration are equal. So we know normal component of acceleration, that means centripetal acceleration, mv square by r, is equal to tangential acceleration dv by dt. Okay, this they have given already, right? So this is, tangential acceleration is dv by dt and centripetal acceleration is v square by r. R is radius here. Okay, if its speed at time 0 is initial speed they have given, okay, initial speed they have given, the time taken to complete first revolution. So first of all we need to try to find out this integration. So of course mass is not there, I think this is v square by r. Mass will miss force, it will come. Okay, so v square by r is dv by dt. So dv by v square comes as dt by r. Okay, so radius is 0.5, right? In meters, let's keep it. Okay, so from here we can integrate now. Let's integrate. So 1 by v square integration, correct? 1 by v square means v per power minus 2, right? So v per power minus 2 means integration minus 2 plus 1 by minus 2 plus 1. Or if you know directly, you can write 1 by v square integration is minus 1 by v. Directly you may write. Okay, and it is going from where to where? Initial velocity they have given, right? 4. Final velocity we don't know. Initial time is 0. R is anyway constant. This is 0. Final time is t. So velocity is a function of time. We'll calculate. So 4v, and this will be, radius will come out. Radius is 50 centimeter, which is 0.5, and integration dt is t. Okay. So let's first find out this relationship. So we get minus 1 by v plus 1 by 4 is equal to t by 0.5. That means 2 will go in the numerator, right? 2 will go in the numerator. Okay. So from here 1 by v is what? Bring 1 by v one side, 1 by 4 minus 2t. Okay. So then what do we get as v? V we get as 1 divided by 1 by 4 minus 2t. Okay. First of all, we need to get this. This is how velocity changes with time. Now they are asking what? Time taken to complete the first revolution. Let us try to do time. So here v, remember v is the speed here. Okay. And because tangential acceleration is rate of change of speed, instantaneous velocity it is. So v can be written as dl by, this is speed, so I am writing dl by dt. Okay, so this will be 1 by 4 minus 2t. So dl is dt divided by 1 by 4 minus 2t, and let's integrate now. Okay, so what do we get? So dl means the total length of a circle, which is 2 pi r, right, for one revolution, and initial time is 0 to, this will be time period here. Okay, so you will take, this will become ln 1 by 4 minus 2t, and you need to substitute initial and final. So finally from here you have to solve. The radius is how much? 0.5, right? So this will become 0.5, and then ln you put the upper limit first, so 1 by 4 minus 2t, and log a minus log b, so it will become 1 by 4. Okay, so solve it from here. So this will be pi, and this will be ln 1 minus 2t, so that will become factor 8, right? 8t. So then you can write here as e per power pi, it will become, correct, e per power pi is equal to 1 minus 8t. So from here t will be 1 by 8, 1 by 8 1 minus e to the power 5. Correct? Let's check the answer. Minus 2 pi. Why minus 2 pi is coming? Minus 2 pi. Velocity we have got correctly. Okay, 1 by 4 minus. I think we need to also divide by the coefficient. While integration, this is important point. So coefficient of t is minus 2. So we need to divide it by minus 2. Yes. I think when you do that, there will be a factor of minus 2 coming here. Okay. So this will become minus 2 pi. Okay. So this will go minus 2 pi. That's why this minus 2 pi factor is coming in the numerator. So we need to take care while doing the integration that minus 2 pi factor is going to come here. Okay, the coefficient of this time is divided. So there can be mistake in such complex type of questions. So there are some questions which are little bit complex. Okay, so the alpha value is coming as 8. We can just compare with this. This factor is coming as 8. Okay? This factor is 8. Okay, then let's move to the next. Next question, displacement and the increase in velocity of a moving particle in time interval of t to t plus 1 are this and this. Okay, in the time interval. So time is equal to t to time equal to t plus 1. Right. So this is the instant 1 second only. Okay, the velocity is given, displacement and the increase in velocity of a particle. The displacement and the increase in the velocity of a particle. So in this interval, they have given 50 meter per second. It should be. Okay, so I think this is displacement and the increase in the velocity, then it should be like meter per second, isn't it? Okay, anyway, but this displacement is 125. It is okay. Increase in velocity, that means suppose this is u, this will be v. Okay, the distance traveled by the particle in t plus 2th second. T plus 2th means from t plus 1 to this t plus 2. Right, this is what it is. This is t. T will be t plus 2. T is equal to t plus 2. In this time, what will be this distance? X they are asking. Let us say that this is x. So if I take initial velocity u, we don't know what it is. So what they have given is v minus u. Change in increase in velocity is 50, and this displacement in tth second. So this is actually tth second, and this will be t plus 1th second. So can we use that equation? Displacement in tth second formula is u plus a by 2 to n minus 1. Nth second is speed formula. So if I am using, so 125 is equal to initial velocity we don't know, acceleration also we don't know. So first is 2t, this is tth second, 2t minus 1, right? So we have this equation. Next, they have given also the, so next we want to find x. So what will be x? X will be, now here it is v we have to start, right? This is the initial velocity v we are taking. So v plus e by 2, here it will be t plus 1th second, right? So I think u should we keep as the same or different? I think we should keep at the same initial velocity. Time is measured from the beginning. Some time t is equal to 0 will be there, right? Some time t will be equal to 0. But one thing to note is that if you take time 0, then what will be the velocity, that we don't know, right? Here, what is the initial time we take? There is what we say that difference of velocities, right? U and v. So can we use this formula? Sn is equal to u plus c by 2 to n minus 1. That's what we need to think about it. Because if you take this initial velocity cannot be here, because this is at t second it is. Okay. So initial velocity is u means some initial velocity. and this is a by 2. Okay, let's take u as some initial velocity when time was 0. When time was 0, the velocity was u. And here velocity, let's say v1, this velocity, let's say v2. Okay, let us say this is, so they have given then difference of v2 minus v1. v2 minus v1 is given. Let's use this formula, and v2 can be written as v is equal to u plus at. So if you write v2 as u plus at, acceleration, that time is t plus 1, right? Similarly minus, you can bring this down. Okay, so similarly velocity at 1 means v equal to u plus at. Here u, and when you open the bracket, minus at is equal to 50. So I think you will get cancelled, 80 get cancelled. So acceleration we are getting as 50. Okay, acceleration will come like this, right? Then now you can use this u plus a by 2 2n minus 1, and similarly x will be equal to u plus a by 2 2n. So here this is 2t plus 1, right? Minus 1. So how much this comes? I think you can subtract this equation, then we can fastly solve it, right? So subtract 2 minus 1, so you will get x minus 125. U factor will get cancelled, a by 2 taken common, right? So 2t 1 will get cancelled, 2t plus 1 minus 2t, so just 2 will come, right? That means x minus 125 is equal to just a. X will become 125 plus a value is 50, so we'll get as 175, right? So good question, right? Tricky question. So we need to use properly the values which are, and so this answer will be 175. Okay, so because initial velocity is starting when time is 0, so that is different than here v1 v2, these velocities. Okay, let's move next. Next question, relation between time and distance x is this. So time is equal to alpha x square plus beta x. Okay, alpha beta constant, relation between acceleration and velocity. So differentiate time with time, 1 alpha x square with x we have to do, so 2x, then x with time, that is velocity. Similarly beta comes out, x with time is velocity. So here we can take 2 alpha x plus beta common, this is the velocity, right? So we can write this velocity as 1 by 2 alpha x plus beta. Further differentiate to get acceleration. So dv by dt, again chain rule you have to use. So 1 by this differentiation with respect to this, so you will get minus 1 by 2 alpha x plus beta whole square into this with time, right? So 2 alpha x you will get, then x with time is velocity. Chain rule you have to use here. Okay, I'm just directly doing it. Then from here 1 by this will become v square, right? And then this is 2 alpha v. So finally you get acceleration as minus 2 alpha v cube. That will be the answer, correct? So minus 2 alpha v cube, first option. Then next, let's take this question. Small steel ball is dropped into a long cylinder containing glycerin. Which one of the following the correct representation of the velocity time graph for the transist? Okay, so as you drop object, so what will happen in a liquid, as you drop it, so initially there will be acceleration in the downward direction. So if you see forces at an instant of time, if you see, there is mg force, but there is a viscous force also. This viscous force is given as minus v into v. So as velocity increases, the viscous force increases, and at one point equilibrium is achieved. So equilibrium happens when acceleration will become 0, then, right, net force will be 0, equilibrium. So then velocity will become constant, and this velocity is also known as terminal velocity. So you will see that velocity will become constant like this. Okay, after that it will going to become constant. So this is the correct answer, option number 2, right? So thank you for your attention. I hope you have understood all these questions, right? then we will be moving to the next chapter. Okay.